Hello students. So this is our third and last segment in which we will study about the third mode, that is radiation. So what we got to know from the last two processes we studied, that is conduction and convection, that they need medium to transfer the heat. Likewise, in conduction, both the mediums need to be in touch and the molecules vibrate faster. In convection also. Okay, but there is one process that don't need any transfer. Oh, sorry, that don't need any medium. So it is the process of transfer of heat in which heat is directly transferred from the hot body to the cold body, and a material medium is not necessary or required, like in convection and conduction, where transfer of heat requires a medium. So here you can see this, as the logo fires are lit over here, the warmth of the wire is coming directly without any medium. For example, sitting in front of a bonfire and feeling the warmth of the fire, the rays of sunlight reaches earth even when the matter is not present. So the energy transferred during this method is called radiant energy. So the radiation that reaches to the earth during this process is known as radiant energy, and it does not need a medium to get transferred from hot body to cold body. Radiation can take place whether a medium is present or not. So the heat comes from the sun that comes to us through millions of miles of empty space by radiation only. So radiant heat. So we got to know that all objects around us radiate heat to the surrounding. For example, our body radiates heat to the surrounding and receives heat from it by radiation. Higher the temperature of the object, the more is the heat radiated by it. So next is absorption, that how body absorbs the radiant heat, that is the energy transferred by the radiation process. Radiant heat travels in the same way and same speed as light. When light falls on the object, it is partially absorbed and partially reflected. A part of it may be also transmitted through the object. But partially absorbed means that it gets absorbed into the object. Reflected, that is, it is changes its path and goes back. A part of may be transmitted through the object, that is, it passes through the object. So in the same manner, when radiant heat reaches an object, it is partially absorbed, that is, some of the energy gets absorbed into the object, and partially reflected, that is, some of the energy gets back with the path changing of path. A part of heat may also be transmitted and absorbed. Part results in the increase in temperature, that is, that increase in temperature is due to the transmission and the absorbent of the object. The energy which is absorbed by the object is the result of the increase in temperature. So here is one diagram. So sources of it is some source of heat, and heat energy is coming from that source into the object. Some of the energy gets transmitted, that is, passes through the object. Some of energy gets reflected, changes its path and goes back, and some of the energy gets absorbed, and this absorbed energy is the result of increase of temperature. So there is one activity that we will perform which shows that the dark colored object absorbs radiant heat more quickly than the light colored object. So what we have to do is, we take a black painted tin can and a white tin can of same size and place them separately. Pour same equal amount of water in both the tin cans and fix thermometers. The initial temperature of water in the both tin cans are noted, and we place both the tin cans in bright sunshine for 1 hour. Actually, what we have to see that which of the can will absorb more heat and quickly. The heat radiation of sun will fall equally on both the tin cans. After 1 hour, we note down the temperature of water in both the tin cans again, and we will find that water in the black tin can is at higher temperature than in white tin can. So what exactly happened? Same radiation, same heat is provided by the sun, but the temperature of black tin that is painted black is more than the temperature at in white tin. Since the temperature of water in black tin can be is higher, it shows that the black color tin can be or has absorbed more heat of sun, and the lower temperature of water in the white tin shows that the white color tin can absorb less heat from the sun. So what we go to know from this activity that a black object absorbs more heat radiation than the white object. Since a black object is a good absorber of heat radiation, it means that a black object is a bad reflector of heat radiation. That is, much of the heat energy gets absorbed in the black color, dark color object, and so much less of the energy gets reflected back. Since a white object is a poor absorber of heat radiation, it means that white object is a good reflector. That is, it does not absorb much of the energy, so it is a good reflector as it reflects most of all its energy back. So this is the scenario. One tin is black, we have colored it black. One tin is light in color, and you can see that we have a placed thermometers to check the temperature. When we place these tin cans in the sun, what we will see that we get a higher increase in the tin colored black colored tin than the light colored tin. One activity also will be performed, that which of the object out of the hard dark color and low light colored object loses radiated energy. So we take a black and tin, exactly same scenario will happen. We will note the initial temperature, then we will allow what we have to do it, we have to fill. Last time we had filled with normal water, but in this activity we will fill with hot water, and we will check the temperature. Now allow both the tin cans to stand for 10 minutes. After 10 minutes, note the temperature of the water in both the tin cans again. What we will find that the water in black tin can is at lower temperature than the water in white tin can. So what we got to know that from this, that black color tin can loses its heat energy or radiate energy faster than the white can. So due to this phenomena, or due to this its efficiency to absorb energy, radiate energy quickly and losing its radiate energy, we get some applications of radiation on this behalf. That is, we wear light colored clothes in summer as they absorb less radiate heat and keep our body cooler. So we always wear here you can see this is the white color t-shirt. This is heat is reflected by the sun is reflected back, and much of almost the heat, very much heat gets absorbed in this light colored cloth. But in this scenario, the dark colored clothes are suitable for winter as they absorb most of the heat radiated by the sun. Electric room heaters are provided with a polished metal surface behind the heating element. This surface reflects almost all the radiant heat from the heating element that falls on it. So in this heater you can see that there is some shiny surface behind that heating element. This shiny surface helps to reflect almost all the heat from that heating element into the surrounding. Another one, some good and daily basis used example is thermoflask. I think almost all the children are using this thermoflask. A thermoflask is a household item that is used to keep things warm or cold for long time. What exactly happens in this thermoflask? That heat will remain inside, or it does not get lost to its surroundings. So let's see. It consists of a double walled vacuum flask. A vacuum flask is a bottle made up of glass or metal with hollow walls which are evacuated of air and sealed together from the neck and bottom. So here you can see this is a vacuum flask. They are hollow walls which are evacuated, that is air is evacuated from them, and they are sealed together from the neck and bottom. The walls are silvered. The vessel is put into a metallic case and separated from it by the cork. So vessel is put into a metallic case, and there is the walls are silvered. So, the vacuum between the two glass walls considerably reduces the flow of heat by conduction and convection. This is because both the modes require medium for transfer of heat. The silvered surface reflects the heat back, thus reducing the radiation. So, this is double glass walls, which are the poor conductor, so they does not let heat lose its to its surroundings. Then one silvered surface which prevents the radiation, because we have to take care of all the three modes. So this vacuum helps in no conduction and no convection. This silvered surface will helps in prevents the radiation process, and insulation supports will reduce the conduction and supports the vacuum chamber. Now one insulated cover is given over there which prevents the conduction of heat and convection of hot air. So this is how thermoflask or vacuum flask is made, so that the liquid inside that thermoflask remains heated or remains in heat or remains cold. So thank you. This is all for now. We learned about conduction, convection, radiation, and conduction is, I will give you a quick view. Conduction, heat travels from molecule to molecule without molecules moving. Convection, heated molecules in liquid and gases move to carry heat. Radiation, heat travels as without any medium. So thank you students. Thank you for listening.